this lesson, we'll be solving systems of equations using graphs. So by the end of the lesson, you should be able to graph both from an equation and from a table, and find the solution/intersection of the two lines. So to solve the systems of equations by graphing, you have to graph both of the equations, and then find that point of intersection, and then use this ordered pair in both equations just to check and make sure you have it right. So from tables, you simply look at the table, and the solution is where the x values and the y values are the same. So you can see in this table, the x is 3 and the y is 2 in both of the equations. So that's the solution to the systems. So here we're going to compare the tables for both the equations to find the solution and then graph it to check. So if I use my equation y equals x minus 7, in my table I plug in 0 for x, so I get y equals 0 minus 7, so y is negative 7. If I plug in 1 for x, I get y as negative 6. If I plug in 2, I get y as negative 5, 3, negative 4, and 4, negative 3. And the second one, if I plug in 0 for x, I get y is equal to negative 2, because 1/4 times x is 0. If I plug in 1, I get y equals, would be negative, put in the 1 for the x, would be negative 1/4 plus minus 2, which would be negative 2 1/4. If I plug in 3, I get negative 2 1/2. If I plug in 3, I get negative 2 3/4, and if I plug in 4, I get negative 3. So then I'm going to graph both of those. And this one, I begin at negative 7, and then my slope is 1, so I go up 1, right 1. In this equation, I begin at negative 2, since they're both in slope-intercept form. My slope is negative 1/4, so I go down 1, right 4. Let's graph both of those. And you can see that our intersection, the blue one here, is beginning at negative 2, going down 1, right 4, down 1, right 4. And the other one is beginning at negative 7, going up 1, right 1, right 1, up 1, right 1. So where do they cross? They cross here at 4, negative 3. All right, determine the solution in the systems of equations. So the first one, again, is in slope-intercept form. It looks a little backwards, but still in slope-intercept form. So we begin at 0, 2, and we go down 2, right 2. The second one is in point-slope form. So we begin at that point 2, 6, and our slope is 2, so we go up 2, right 1. So let's graph those. The blue one's beginning at 2, going down 2, right 3, down 2, right 3. The red one is beginning at 2, 6, going up 2, right 1, up 2, right 1. So I find that my solution is 0, 2. So if I plug those in my equations, my first equation, I plug in 2 for y and 0 for x. I get 2 equals 2 times 2/3 times 0. So 2 equals 2. If I plug it into the second equation, 2 minus 6 equals 2 times 0 minus 2. So negative 4 equals 2 times negative 2. Negative 4 equals negative 4. So yes, the point 0, 2 is a solution to both equations. All right, determine the number of solutions. Determine the solutions. So the first one is in standard form. So I need to find if x is 0, y would be negative 9. And if y is 0, x is 3. This one is also in standard form. So when x is 0, y is 1. And when y is 0, x is negative 1. So I'll graph these at my two intercepts, x and y intercept, and then I can see that they cross at 5, 6. So now I'm just going to check in both of the equations and make sure that that works. So in the first one, I substitute 5 for x and 6 for y, so I get 3 times 5 minus 6 equals 9. So that means 15 minus 6 equals 9, and 9 equals 9. Works in that equation. How about this one? Substitute 5 for x and 6 for y, so 5 minus 6 is negative 1. So negative 1 equals negative 1. So looking at the equations, can you find the correct graph that goes with it? So looking at this first graph, the first thing I always look at is the y-intercept. And then I look to see if the slope is positive or negative. So based on that y-intercept, and then it's a positive slope, I'm going to say y equals 2/3 x plus 4. In the second one, we're going through 0, 0. So the only equation that goes through 0, 0, the only direct variation equation is y equals 3x. In this third one, I'm looking at the y-intercept, and then I see it's a negative slope. So that one is y equals negative x plus 3. This next one, again, looking at the y-intercept, negative slope, y equals negative 4x plus 4. And this purple one, looking at the y-intercept and the slope of the line, I can narrow it down to y equals negative 1/4 x plus 1. And then the last one is y equals 3/4 x plus 3. So can you graph the equations in any form? Yes, of course. What is the solution to the systems of equations? Where both lines intersect, that one point.